Um, Good morning. This is the other homework problem that I noticed that my students anyway had trouble with. I don't have access to your Pearson, but this is what I noticed for my own students in intermediate algebra. So this is homework number 3, and it's a graph of a parabola and of a horizontal line. Your parabola and your horizontal line might be a little bit different, but you should have a parabola and a horizontal line. For my problem, when I was assigned this problem, my parabola is, I have to add f and g, and f is 7, and g is x squared minus 1. So if I look for like terms as I'm adding, I would have first I would have 7, and then I would have plus x squared minus 1, and x squared is my largest exponent, so usually when I write things in the standard form, I start with my largest exponent, and so I would write that first for my final answer, so I would write x squared, but then I also have some like terms here with my constant terms. My 7 and my negative 1 are both like terms, so I can add those ones together. So 7 plus negative 1 would be 6. So my new parabola is going to be an x squared parabola, except shifted up 6 units. So I'm looking for a parabola that has a y-intercept of 6. I can right away, as I look at, it has a y-intercept of 6, and it has the vertex is at 0, 6. As I look at the options here, I can eliminate option D right away because that y-intercept is negative, so I know that's not going to work. I can also eliminate option A because that looks nowhere near 6. In order to find the choice between B and C, I kind of popped them out and took a look at them, but I want to point something out that Pearson did, which I'm not sure I love. Pearson started counting here at 4. So this line here, that little dotted line there, is a 4. So this would be 4, 5, 6, 7, 8, 9, 10, all the way up to 18. And I had to pop it out in order to count those carefully, but that's how I knew that option B was the correct answer, because I started at 4 and then that vertex is at 6. That's a shifted up 6 units parabola. So that might have been why my students were missing this question, was that graph B is a little bit misleading. But I actually think the other reason that they were missing this question was the last part of the question asks about domain and range, and so you have to do some kind of deeper thinking about the domain and range. The first thing it says is the domain of f plus g. So that's this guy, the domain of that function. Or it's this graph in B. If I look at both ends, I've got arrows on both ends. And so the domain is going to be all real numbers. Or remember, in interval notation, we would say negative infinity to infinity. But I think that the choice on Pearson is all real numbers. If I look back at the original f and the original g, well, both of those also have arrows on both ends. So actually, that's the same domain as the original two functions. If I look at the range, though, the range of f, which is just 7, well, the highest point and the lowest point are both 7. So f has a range of just 7, and g has a range of all numbers bigger than negative 1, because it starts at negative 1 and goes to infinity. But my new function, my f plus g function, that one starts at 6. The lowest point is at 6. If I were doing it in interval notation, I would say from 6 to infinity. And if I were doing it in in equality notation, I would say my y-coordinates have to be greater than or equal to 6. And the range is not the same. The range is different from the original functions. So when you make your choice for that domain and range question, while the domain stays the same, the domain will still be all real numbers, the range is going to change because when you add them together, it's going to wind up being a shift of your graph, which will change your range. All right, I hope this helps for homework question number 3.